hot, hot. Okay, looks good. Can you guys hear me? I cannot hear. I see. Mm-hmm. Hot. Can you guys hear me? Do I sound good? Perfect. Thank you. Um, And I think that it's time to start our semester. 3:30. Hello, everybody. People will slowly join. Just mentioned Zoom compress the video a bit too aggressively and compressed it even more when I upload it to Pinapto to D12. Let's wait a second. So you have in the chat, I stream now in Twitch, which by the way also record it, but then there is a, I think, 30 seconds delay. So maybe I will try YouTube next time as a streaming device. But of course, you see me as a virtual camera in Zoom itself. So we're going to start course that I'm teaching so many times, but I think that the material and the adrenaline rush and the type of topics I'm talking about, it's stuff that I at least close to my heart, really enjoying teaching this course. And we will talk about algorithms, well, as the names kind of hints. It will be myself, Alon Efrat, here since the dinosaurs ruled the Earth, joined the department at 2000. Together with me, Jacob Miller, Fan Lu, and Pritula Haridi will be our TAs. We will have, you will meet them in the office hours, of course, but also you'll have a chance to meet them whenever we will have active learning sessions. I'm not going to be extremely formal and in what is exactly the active learning is, but because, you know, if you check the textbook or talking to the people that are loyal to active learning, there is a long set of rules of what makes active learning, so we are going to do it a bit less formally. From time to time, every third or fourth meeting, I'll give you a few questions, break you into rooms, give you some time to work on these questions. Yeah, and that's about it. And then after these 10-20 minutes, breaking you into rooms, it's times that you're working on each problem. I and the TAs and me, so we will walk around between the rooms and chat with you and try to steer the discussions. During this session of active learning, your webcam should be on, unless you have some really emotional / technical problems that really prevents you to have the webcam on. For the active learning only, it's pretty strong requirement from you to have your camera on, so you'll see people face to face. There's still a lot of that can say about face to face that you don't get in voice only when we are breaking you into small groups and trying to get you to work together. Yeah, and I'll definitely prefer you with webcam on when during my lecture, but it's not a requirement. I just have many more cues about, am I speaking too fast? Am I speaking too low? Do I understand each other? There is tons and tons of hints that are passing in video that I can guess where you are in getting what I'm saying or not, or what should I rephrase. Okay, so webcam on is a good thing, and it's a pretty much requirement unless you have reason, and tell me if you have a reason why not to have it, of course, for the active learning. And it's a very strong requirement during the midterm and the final exam. That's as you know. Web pages. So we are using a lot of resources, a lot of servers in this course. There is, you will see the course website, which is a Google Doc. I think that's the easiest to update or to change things. You have a link from it, both from my personal homepage as well from D2L. D2L we are not going to rely on too much. All the recordings will be also on Pinapto. That's for sure. Everything will be on Pinapto as well. And on Pinapto you also record the class discussions and the Zoom part. If you don't want your name to appear in the recordings of Pinapto, then let me know and we'll figure out. There are technical solutions to how to make sure that your name doesn't appear. But still in the discussion you'll appear. However, that's only on Pinapto and that's accessible only for the core students. Pinapto compress the video quite aggressively. I was trying to request that it wouldn't happen so far. For now, it's still happening. So I'll try to record it or to have a recording also on other servers. And for other servers, it's just me speaking and the only the camera and the whiteboard. You don't see the chat and the input that Zoom introduced. Now, the homework will be submitted in Gradescope. Only theoretical homework, excluding maybe something small about optimization, but that is just a tiny MATLAB or Python script, maybe. It will be a very small part when we'll talk about linear programming. But in most times that I taught this course, it was only theoretical homeworks, which you can submit to Gradescope, and in Gradescope you'll also go to see the reaction, the feedback of your homeworks, of your submissions. And probably the midterm and the final will be on Gradescope as well. Submit them to Gradescope as well. Piazza, it's about course communication. First, all the announcement from us, the course staff, will be on Piazza, and you are encouraged with some strict limitations that I'll tell you, but you are also very much encouraged to have discussions between the group itself, you as a public, in Piazza as well. So you definitely need Piazza. Now, when I'll post the homework, and homework 0 I'll post in the next day or so, that is just a few questions that will let you answer things that you already know very. It will be 1 point in your final grade, and it will only check that the mechanism of you reading the homework, writing the solution and submitting to Gradescope, that it works for everybody. So we wouldn't have any issues in the real homework. I'll also use this opportunity to tell you your handwritten is unacceptable, or it's fantastic format, or any other warning sign that might be a real issue for the real homework. So we'll have a simulation homework with tiny little weight assigned to it, no more than 1 point in the final grade. And when I'll post the homework, I'll post a link to Overleaf, web page called web server called Overleaf. And when you'll open it, it will look like something like this. So you are opening the link that I sent you, and on your left-hand side, you'll see the LaTeX description of the homework. So that's LaTeX. If you know LaTeX or you want to study LaTeX fantastically, it's not a requirement. If you can, one of the reasons I'm giving you access to the LaTeX is also so that you can write your answer directly on the web page, on the document itself. Or you can download the PDF. You're placing your mouse right here and clicking download after recompile. Click recompile first, and then you're clicking download, and you'll have the PDF directly. You can also so you will need to subscribe to Overleaf, but unless you're using more than 2 gigs, it's for free. So and there is a rich text that you can use that makes it a bit more like Word or Google Docs. If you prefer it, somewhere along the middle of the way. It's not entirely smooth, the rich text, so you might as well just work with the LaTeX. And the reason that I prefer to send you a link to Overleaf instead of sending you to the PDF directly is that later on there is some clarification about question 1. Yeah, that's one of the nice things about Overleaf is that you click on the PDF and it takes you to the corresponding place in the LaTeX. There is some question about homework 1, and then I'll writing and then I'm adding a comment after because somebody asked a question and I realize that I asked something that is obviously not true, or just clarification comments that I want in the body of the homework. Usually people have a request about the clarification. It's easier to just add it directly into the LaTeX. And when I'll do it, if it's after the post, after I post the homework, probably I'll also do it and I'll add to it. Huge blue, I click recompile or click alt return, control return, and then it appears, and hopefully that's a typo, sorry. Yeah, and then my comments will appear in a different color, so you can actually see it in a, sorry, you didn't, I see the problem. There is a problem in homework 1. I went to the LaTeX. Overleaf is very nice by you double click on the LaTeX, on the PDF, it will take you to the corresponding place in the LaTeX and vice versa. And I just added this comment that says, ignore this question if it's after I already post the homework. Hopefully this will never happen, but clarification comments might definitely appear. So that's about Overleaf. There were any other questions? When you submit the homework, you can generate them in any way you want. LaTeX is one version, handwriting is another one, drawing figures, handwritten, and then adding it to the text in one way or another is another one. Combine PDF, Word, Google Doc, anywhere you want. Handwritten is also absolutely fine. You are responsible for the grader and myself, TAs and myself, should be able to read it conveniently without fighting with your hand, decrypting your handwritten, and the fact that page 5 continues 5 pages later with everything that makes the reading unacceptable. It's your responsibility to make it readable at the end, and it needs to be submitted as a single PDF per homework. Every homework submitted as a single PDF. Questions? Oh yeah. And as you play with Overleaf, you'll also see that it's quite easy to add figures, add figures, add drawings, anywhere you want. You can add images, you can include other PDFs, you can scan places and insert it, etc. Okay, and that, I think, summarizes all the websites that we are using. So if you haven't done so, first priority, get registered to Piazza. This little drawing that you see right here, this little, yeah, question? Yeah, this little drawing that you see right here, it's going back 3-4 years to times that I taught it. I taught algorithms 4 years ago, I think, where that was known as a cs445 salute. And why this gesture is a 445 salute, we'll see much later in the course. But okay, it's a theoretical course which makes the boundaries between brainstorming and group discussion versus cheating. These boundaries are not always clear, so I'm trying to tell you here what is completely acceptable and encouraged versus what is a big no-no and will consider cheating. So here is an algorithm that I suggest that you'll take when you have to solve the homework, to prepare your homework. So read the questions in the homework and go to lectures of the course, go to lectures of other people. A lot of people teach algorithms and have videos online. I'll publish a few links that I particularly like, but you can find materials all over the web, and see the lectures again if you didn't understand any of the algorithms, so the examples that we discussed. After you're doing it, take your time and think about the problems, okay? And try to come up with ideas that work, come up with ideas that don't work and why they don't work. Okay? Understand what's going on in the question. Now meet 2-3 other students. 2-3 is a fine number for group discussions. Piazza gives you way to find teammates to work with, and have brainstorm. This slide is obviously written when I'm referring to physical meetings, so you'll convert it to what's the equivalent of a virtual meeting, but essentially meet your peers and discuss the high-level ideas. Let everybody suggest something. Don't be a slacker. Don't listen to other people. Come up with your own thoughts so you'll be an effective member of your team, and then go home virtually. Go home again, and you have to write the solution yourself based on the ideas that you understood together. That is, it's fine to talk about the high-level ideas. It's definitely not fine to take somebody else's written solution and write it yourself. This And that should be how you should address all the homeworks. And uh, take my word, because I'm doing it for enough many years to tell you that if you are not following this algorithm in some way, for example, you're copying somebody else's solution without understanding it, you are using web resources that you are not supposed to use web resources. I know about them. Uh, I'm not always impressed from the quality of the solutions to the homeworks that the other resources publish. But if you're using illegal tricks here, catching cheating in theoretical homeworks is much less well defined than cheating between programming software that you are submitting. So possibly you'll get away from it by cheating, and you'll increase your homework grade, but I'm kind of guarantee that it will really affect badly your exam grade. I'm trying to write the exam in a way that if you thought about the homework questions and really understand what's going on, then the questions are not too hard, but my questions in the exam will be related, will be similar, but not identical to homework question. So if you are very familiar with really the essence of the question, the exam will be easy for you. If you are not following it, then you're cheating, or you'll get bad grade, or both. Okay. So to summarize, collaboration is good. Moreover, tell me with whom you collaborated. Just give credit. Again, it's legit. Tell me my team contains Mr. A and Miss B. These are the people I'm working with, and that's fine. And Mr. A gave me the solution to the first question. Mr. B gave me the solution to the second question. I contributed this. Give us a little page that gives credit. It's absolutely fine. Okay. Yeah. Thanks for. I see that the chat is at the meantime. Uh, yeah. So give credits. You can even specify in percentage wise, and that's absolutely legit. If you are sharing text with anybody, it's cheating. And there is another way to cheat. I'll refer to it very soon. There is another way to cheat, even if you don't mean to. If you'll go to Piazza and you're creating a public post which is absolutely fine by itself, but your question sounds like, are we allowed to use quicksort for the solution of homework in homework 3, question 7, when my question was suggesting algorithms that arrange something in something? And you are now suggest already that you might be right, you might be wrong, but you think that part of the solution starts by let's use quicksort, say. You're hinting to other students that quicksort is a correct direction to go, even if you're right and even if you're wrong, and if your intention was completely legit, I'll consider it as cheating. And it's not as severe as publishing the results directly, but don't publish anything that sounds like a hint about the way of the solution. Okay, be careful not to publish anything that sounds like a hint. Every semester there is somebody that I need to block for a week from Piazza. I don't think that it ever get to anything beyond it, but oops, there is a typo. But if you have any doubt if the question that you want to ask is legit or not, you can limit its visibility. Don't confuse it with sending it anonymously. Anonymously just removes your name. but I can still see your name. Send limits the visibility of the post so only the staff sees it. And if we think that it's a good point, we'll publish it to the whole public. Or I'll say, yes, it's a good point, but I don't want to spam somebody's emails right now, so I don't. But here is the answer to you. So I'm making it more complicated than what it is. Don't give other any hints about what your solution is, but beside it, be a productive member of asking for clarification. It is counted toward your class activity. Your class activity altogether is something that I'll talk about, and I like people that are active on Piazza, by all means. And what else? Our grading scheme. I have a funny grading scheme that has one downside, which is that I cannot run it on D2L directly. I have to use, maybe I do, but I don't know how. I have to use spreadsheet to compute your final grade. So I cannot share the spreadsheet with you because you are not supposed to see other people's grade, but I can share with you the template of the spreadsheet, and then you can type your grades and see what you're getting into. Okay, so that's how you compute your final number, but that's my spreadsheet. It's all the details is in the document, in the Google Doc of the course. In particular, what I like about it is that I look at your midterm, I look at your final, and I think that you didn't do well in the midterm, but you pulled yourself together and did great for the final, then the final gets more weight and the midterm gets less. And the other way around, if you did much better in the midterms than you did in the finals, then the midterm get more weight. So that's one trick that I'm doing it. However, this semester you cannot do terribly in the final as well. You cannot say I got 100 in the midterm, so only the numbers count, because there is some limitation that if your final goes below a certain threshold, it will affect your grade, nevertheless. So that's all. We will have 7 homeworks. I look at the lowest one, and that's the one that I drop. Okay, 7 real homework, not including homework 0. Video recording, we talked about it. I already put on the Pinapto Dropbox a recording from an online course that I gave a few years ago in one of the summers of the same course. It's not perfectly arranged, but you can get what the topics, and I think that 80–90% of it at least are shared with this course. So if you want to see what you're going into, or you want to check these videos, go ahead and go to the Pinapto web, to the Pinapto folder in D2L, and there is a subfolder for recording from last year's. And if people want more recording of this type, I'm happy to share. I recorded it for more than one semester. At the moment, there is one semester there from 2016 or 17. Okay, prerequisite for the course. If you did fantastic in 345, it's great preparation. If you didn't take 345 or did poorly, you still might get away in this course. You'll talk to me and I'll tell you what things to cover. I mean, I'm not going to use anything without explaining it. So this course is self-contained, but for example, about big O and omega and theta, that at least big O I hope that you saw before, and recursion formulas that I hope that you saw before, I'm going to spend little time. So if you need more practice about it because you didn't take 345, make noises, and I'll point you to the correct resources. Okay, not to share hints about the post, we already said it. Attendance, I am not going to check each and every time if you were or you were not from time, but I do accumulate something like my overall impression from each of you as a student, my own and the TA's impression from each of you individually. Are you active in class? Are you the one answering the homeworks? Are you the one that catch typos if there are immediately? Are you trying to be good colleagues in the group discussions? Um, how many bonus points did you accumulate, and so on. So I have something that I'll think about the overall impression from each student, and of course, participate in the in the classes is a good thing. Answering my questions is even better thing as a class discussion. And where this class discussion are taking into account is where we are computing the final grade. That is, if you will get day 90 in the final and you get 90 or above in the final and you get 80, sorry, you get 80 and above in the numeric course grade. Yeah, I mean, after we apply all these formulas that you'll see in the website, and you didn't shoot yourself in the foot by flanking the final, you get at least 80. Maybe I'll play with this number, but probably at least 80 in the final. Then I guarantee you will get an A. So that's a sufficient condition for you to get an A in the course. However, you might get an A even if you got 88 as your numerical average, sometimes below, sometimes above, but that's kind of bumping you up if I have reason to think that you are deserve to be bumped up. And that's where my overall impression about everything that you did in the course, that's where it comes into account. Right. The more you're doing it, the more reasons that I have to think that you are a good student. And the same goes about recommendation letters. If you're usually between 20 and 30% of the students will end up with an A, slightly less, slightly more. And if you are getting, say, an A and ask for a letter after that to get to Harvard, I might say that just based on your grade, I can say that you're among the best 25% of the course, but maybe that's quite lame. If you're the one that solved all the bonus questions and that fantastic grade all over the place and was very active in the course, my letter is much more meaningful. Okay. Any questions so far about the bureaucracy? Textbooks. None of the textbook is an absolutely must. I am playing, my slides have been helpful for literally thousands of students before you in this course. I'm proud of them. You can get away by just the course slides. If the course formal textbook is CLRS, because it's Corman, Lyserson, Rivest, and Stein. In some topics, a few topics that are not here, some of them are here, like the stable marriage that will be our first topic. It appears in this book. This book, I didn't see that you can get it electronically as opposed to this one. I saw it on Amazon for $30 right now. But usually its price is much higher. That's was one of the reasons that I didn't recommend this, even though they are both fantastic. There is the Dasgupta book, very nice. There is a link from my website. And for skip list, which will be our next topic, you will have description of skip list that I like over here. That's an older book. Used one I just picked up Amazon was for $1.73. I'd be happy to finance it for the ones of you that do not. Older book, but modern enough and explained. And in data structure, it has some really beautiful explanations that other books are lacking in some of the data structures. But in particular, skip lists that will be that is coming up. Okay, that's about the textbooks. Of course, I'll add some links to lectures that I like. Let's talk about why are we studying algorithms. We will discuss problems. I collected a collection of problems and algorithms that solve these problems, but this collection is just one possibility out of a huge sea of other algorithms and other topics that I could have picked. And the reason that I picked these algorithms, I need some explanation of the ways that I picked. How did I pick this algorithm? And by the way, this course is different than the way that other people, even in this department, teach algorithms. It might be different than the courses that you find elsewhere. There is a lot of intersection, but there are a few topics that I thought that are extremely important and other people felt differently, and vice versa. So how do what's lead you in this big sea of algorithm? I'll own an explanation. Even before that, every time that I'll talk about an algorithm, we'll talk about the complexity of the running time. What is a big O of its running time? What is a big O of its memory? How much memory does it need? How many resources does it need? Sometimes I'll talk the bottleneck for some algorithm would be the memory much more than just the running time directly. Other algorithms, especially if you're using hard disk rather than solid states, the number of I/O operations that you are doing are more critical than the number of CPU operations that you are doing. How many times are you reading a bucket of data from the hard drive or from the SSD? Same goes in your solid state drive. And you are writing a big chunk of data or reading a big chunk of data, and these operations should be pre-planned, and they're much slower. They're slower on SSD, and they're much slower in hard drive. Every time that you are performing an I/O operation, read a lot of data or writing a lot of data. And in SSD, there is even difference between the read time versus the write time. Reading is much faster. So sometimes we'll talk about the I/O efficiency. How many times do I need to read and write elements from the disk? Assuming that I'm working on, you'll have questions that starts by you're working on a huge files. Your file is 3 terabytes. Sorry, you cannot fit it into your own main memory right now, even though you just bought your new computer. and you cannot fit the whole file right now into the hard drive. You have to read pieces and write pieces from the big file into your main memory. How would you arrange it in an efficient way? Okay. And of course, people talk about GPU complexity. That's a bit tricky to measure because there are so many different operations that GPU are doing, and some of them are parallel and some are parallel but local. But there are attempts to measure GPU operations. I don't plan to talk about it too much in this course, but of course, it is an issue, and as you all know, GPU are using to many more applications beyond graphic processing only. The times that GPU were mainly used for graphics application, I think that that's way over. So many algorithms that are implemented on GPUs, and complexity is important for them as well. Okay, so in real life, I'm trying to hint now about the ways that we pick topic for this course. So in real life, many algorithms, even though they are different than each other, they fall into a few buckets, several buckets that these algorithms are falling into, and these buckets usually called paradigm. Now, paradigm that says my algorithm starts by, for example, I'll pick one element from the input, compute my solution, add another element, and another element, and see how my solution is changing. That refers to as incremental algorithm. Or sometimes your solution will obtain by I'll pick the first element, or I'll pick the best element, then the second best, then the third best, and so on, and this will consist of my solution. Then you are proceeding in a greedy way. So greedy algorithm is another paradigm that is very powerful when it works, and we have to study. We will talk about when greedy works and when greedy gives you something that is suboptimal and maybe far away from the optimal. Sometimes we will talk about algorithms that solve something by take the big input, partition the big input into, partition the big input into two subsets, solves recursively to each subset, and then somehow combine the two solutions into one big solution. This is called divide and conquer. Take the big input, divide it somehow into two subsets, or more, maybe two subsets, so compute a solution to each subset separately, and then make from the two solutions a larger solution for the original problem. Which brings us to my first question to you. People, give me an example to such an algorithm that you know. Merge sort. Exactly. Merge sort does exactly this. Merge sort is taking the data, so partition the data into two sub-arrays, sort each one, and then merge them. I'll talk very briefly about merge sort in this course just as an example, but I hope that you all know about merge sort previously. Quick sort is also divide and conquer, but now your idea about how do you divide and how do you merge are quite differently. You're picking a pivot in an array, and based on this pivot, you're partitioning the data into. In quick sort, you are looking at a big array, and you will pick some element x at the array, and you'll make sure that all the elements in this array are all smaller than x, and all the elements in the right side of this array are larger than x, where x is this pivot that you picked. And now the merge process will be much simpler, but I need to keep on recursively on the left part and on the right part by sort using quicksort the left part and sort using quicksort the right part. This is the quicksort algorithm. Hopefully all of you have seen one version or another of quicksort, and quicksort is using idea of divide and conquer, but coming from very different direction. Now, the moment that I perform the partition, then if this, after the sorting, this is here are all the elements smaller than x. The moment that I sorted the left subarray and sorted the right subarray, and the pivot is sitting happily here in the middle, I am done. That's the whole merging. There is nothing to actually do in the merging process. It's only the divide that matters. Okay, so that's another paradigm of divide and conquer, and we'll see a few others. We mentioned greedy algorithms, we mentioned divide and conquer. We'll talk a lot, big part of the course, we'll talk about dynamic programming, some algorithms that you might know but didn't know that they fall into dynamic programming. And in dynamic programming, ideas are usually that I'm not sure what the optimum solution is, but let's make a try by deciding that some element matches with another element. And if that's a decision that we are making, how would we proceed? How will it affect the rest of the algorithm? But because I'm not sure that my original guess is correct, I will also not be sure that I'll get to the optimum solution. But if in my original stage I did the right thing, then I'll be able, at least one of these steps will lead to the optimum solution. And maybe the best example that maybe you didn't know that is dynamic programming, but it is one, would be of finding shortest path in graphs. Maybe you have seen BFS algorithm. BFS looks at a graph without weights and try to ask how many hops, how many edges do I need to jump over to reach from one end to another. Right? What is how many? If my graph is people on Facebook and the edges denote who is friends with whom, and I'm asking is there a chain that leads from this person to this person, and what is the length of the shortest such chain. And at this point, to help me go away from the solution, proceed with the solution, I'll store at each node what would be the distance to it, and hopefully, so what I'm trying to say is here is my graph. That's just a promo to where we are going into. Here is a node S. Here is a node T. And let's denote a few other nodes. And I want to ask how many hops, how many edges do I need in the shortest path that reaches from S to T. And as the BFS algorithm goes, and BFS is very easy to tell you about what BFS is doing. BFS tells you, tell me who are the neighbors of S. Their distance from S is 1. You don't need to write anything. We will talk about shortest path in graph in many more details later. But I'll say the distance, or I look at the immediate neighbors of the vertices from S, and here are all these vertices, their distance from S is 1. I look at the neighbors of the neighbors. Right? Neighbors of the neighbors, their distance should be 2. Their distance should be 2. I will look at the neighbors of the neighbors of the neighbors, their distance should be 3. And of course that would be 4, and finally I'll reach into t. But notice that inside this algorithm, I also computed the distance to this vertex, let's call it w. For some reason, I computed the distance to w. For some reason, I'll computed the distance to u over here. But why? They are not on the shortest path to t. However, I am performing this operation because I'm not sure which of them will lead to turn out to be on the shortest path. I need to do the operation in a certain order, so I'm not sure which of the other vertices will turn out to be on the distance to t. So I'm keeping all my options open. And that's a big idea behind dynamic programming. I'm trying not to make a solution decisions yet throughout which vertex I'm going to end up to t, but I'll keep all my vertex open that maybe I'll go through this vertex or this vertex or this vertex, and that's why I need to know what is the shortest path, at least into these immediate neighbors, because in the big solutions to the whole shortest path, I will use solutions to smaller problem. Again, in the solution of the big problem, find the distance from S to T, you also have to solve sub-problems like what is the distance from S to its two vertices that are much closer to it than T. T is far away, but I want to first find the solution to smaller problems, and from smaller problems, the solution to the immediate neighbors. I'll grow up to solutions to neighbors of the neighbors, and distance to neighbors of neighbors of neighbors, and so on. So that's about dynamic programming. It's an extremely powerful technique. We'll talk about it. We'll see several examples of this technique. Each is a big and important algorithm for itself. To give you promos, the edit distance algorithm, or the longest common subsequence algorithm, a few clustering problem. Edit distance is what you're doing when you want to compare the DNA of two people, or you want to find two texts, two files, and ask how much this file is different than that file. Where are the points that you and me both worked on the same file yesterday, and I want to see what you did and I didn't, and vice versa, then LCS and edit distance will reveal it for us. It will also help us to measure similarity and to correct trajectories that comes actually from GPS and points and trajectories and locations of people to help you do traffic management. Lots and lots and lots of application of dynamic programming. Okay, other paradigms are branch and bound. It says I'll try to explore the whole graph, but I find out that it's too complicated, so with some ideas I'll only explore pieces of the graph. And of course you can always keep on finding a few other paradigms into it. So we'll see a few examples to all these paradigms. What other criteria did I use? I am checking algorithms that I really think that you might need to use in your real life in the future. You might continue into higher degrees, you might go to industry, you might do something completely different. I'll try to teach you the things that I think are most likely to be useful for you in all over. It doesn't mean that you'll always have to implement them themselves, but at least I'll give you tools to see what might work for your problem and either find the library or take one of the existing algorithms and maybe change it a bit so it can work for you directly. That, by the way, will be one of the big reasons that I'll also teach you linear programming. Linear programming is one huge hammer, one huge technique that can help you solve a huge number of problems. Not always you'll find the solution, not always you'll understand how linear programming will reach a solution, but it will guarantee that you can work with this or with integer linear programming, and it's one of the best messages that I can send you after this course to the world about now you know what's the right tools, which libraries to use that can solve so many different things. So usefulness of other topics, important topics, is what dictates algorithms that I pick. And of course, coolness. I want to teach you ideas that I thought that made breakthrough in the algorithmic world, ideas that I would never have reached themselves. Don't know if you, that I think you can take away brilliant coolness, invention over here that once somebody noticed it, it opened the door for, it was very influential and opened the door to many other ideas. People, all good? Questions so far? I'm always, with my ADHD, I'm not always keeping an eye on the chat, so if you have questions, of course, make noises. Yeah, I'll talk to you about at which problems running time counts, which problems maybe you don't care about running time, maybe other resources are more important, as I said. Memory, sometimes the time to reach for the memory, or at least knowing, you know what, I don't care about this problem, I'm just going to implement something naive, and here are, you'll get the feeling that even the most naive algorithm for this problem will probably be fine, because whatever you're doing, it's not the bottleneck of the performances, and even if it is, nobody cares. It's important to know, we are concentrating on performances in this course, but it's important to also know when performances just don't matter, and that's not what you need to waste your time for. Something that I'm doing in this course, and I think that other instructors put much less emphasis on it, is to convince you that randomness could be your best friend. That tossing coins and try to decide, I need to restate the camera location, tossing coins and making decisions based on these coins, head or tail, might be a fantastic tool to make decisions, and sometimes what you can get via a pretty complicated and hairy algorithm, you can compute much simpler by tossing coins and using randomness, and it just works not in a guarantee of 100%, but with guarantee of 99.999%. It will probably works fine, but in return it will run much faster and will require much easier to debug, much less time for you, and much simpler to understand. And I believe that there is at least one example of such an approach that you know about. Where do you use randomness in computer science? Absolutely. Cryptography, I'm using my randomness to generate keys that it's not likely that my adversary knows. And you're actually, but in a friendly world where nobody tries to hack my computer, where will I use the randomness still? And your answer wasn't bad, but where else would I read? Skip list, buy all goods. Maya, where did you see skip list? Okay, who was teaching it? I mean, perfect, very good. I was fighting for a while, and it's still to have it as mandatory in 345. We'll go very quickly over skip list in this course and maybe go a bit into the why they work. But yes, skip list is an excellent solution. Excellent answer. It works when you're tossing coins. Um, other answers? Also in 345? Quick sort, definitely. We talked about the quick sort. We had it on the whiteboard. The best way to pick a pivot is actually to pick one element from the array, or the wrong way to do quick sort if I want to sort my array and I need to pick a pivot X, then some textbook will tell you take X as the first element of the array, which is not a great idea, because if you pick X to be the first element of the array and the array had to be sorted, then now quicksort will use all this time to sort a sorted array, and it will actually take it quadratic time, order of n square and theta of n square. Some textbook will tell you take the middle element of the array, again, depending on who was the one that how the data is arranged. A better way is to pick a random, not a random key. You cannot just come up with a number from your heart, but to pick a random index pick at random an index k from the numbers 1, 2, all the way up to n, and use a k as pivot. That is, I pick one of the elements of the array as my pivot, and then you can prove that this quicksort actually follow its name, satisfies its name, and then it actually runs much faster than anything deterministic that you'll do. And to do it even better, what you should do, don't know if you talked about it, pick 3 keys, K1, K2, K3, all at random, and pick the pivot as a median of these 3 elements. And then you have a great chance that quicksort will be indeed much quicker than other algorithms. Even though, as you know, the worst case running time of quicksort is actually n squared, much less than n log n. There are cases that quicksort, even with all these tricks, will run in n squared, but the probabilities that you'll have to face such a case is quite small. Other examples from 345 where you are using randomness? And, most of you have seen it also outside 345, but